simplify algebraic expressions. So I think you guys all remember the distributive property, but you probably don't know like why the distributive property works, which we're going to talk about today. But let's do a quick review. So it says use the distributive property to expand each equation. So what's the first one, Peter?
So you can put the 5 into the 4. You put the 5 into the 4.
Yes, the 5 goes into both of them, exactly.
Wait, I thought you couldn't do, or no, it's when it's outside of the parentheses, isn't it? That you can't put the, because they're not like terms?
When you can't combine them, we'll talk about like terms today. So, all right, so if I have 5 times 4 minus 5 times x, then I'm going to get 20 minus 5x. Okay, so I distributed, I took the 5 and I multiplied it to both things. So you can also have the distributive property with the number behind it. Most of my math students do not like it when it's written this way, but it means exactly the same thing. So it's 4 times 2 plus 3x times 2. So 4 times 2 is 8. 3x times 2 is going to be 6x. And then multiplying in, if I have 2x times x plus 2x times 5y. What's 2x times x? Yeah. What do you think?
3x squared.
Ah, close. Not 3x squared, though.
2x squared.
2x squared, yeah. And then plus 10x times y. Okay, so it's just like what we did with exponents when you're kind of rearranging the terms, thinking about it in expanded form.
Wait, how does that get squared?
Because we had 2 times x, and remember x times x is x squared, just like the expanded form. All right, and then this last one, I have a negative on the outside. So what this really is like a negative 1 on the outside. So you don't always have to rewrite it with a negative 1 on the outside, but I'll often say things like distribute the negative, and what that means is bring the negative 1 into each thing. So when you distribute the negative 1 into both things, you get negative 1 times 3, negative 1 times negative 5y. So your final answer will be negative 3 plus 5y. So see how the signs inside the parentheses, it was positive 3 minus 5 before, now it's negative 3 plus 5. Okay, so we changed all the signs. Okay, so you don't always have to write these intermediate steps out. Like you don't have to write these steps here. If you guys can skip from the original and say like 5 times 4 minus x is just 20 minus 5x, that's totally fine. Okay? Do we feel pretty good with that? So where does the distributive property come from? So let's talk about these little pictures. So it says write the expression that represents the area of each rectangle. So if you have 4 by 5, then what's the area of the rectangle?
4 times 5.
It's 4 times 5, exactly. So this would be 20. Okay, so that's how it works with just plain numbers. But if we have a variable, so if I have m and 7, then what do we think it is, Cam?
7m.
It is. It's 7 times m, which is 7m. All right, so the next one is going to be 3a, right? And the last one is x times x. Well, what's x times x? X squared, exactly. That's why we say squared instead of x raised to the 2, because notice how x times x is a square, right? It's the same thing for a cube. If we talk about the volume of a cube, it's x by x by x. We call that x cubed, x to the 3, right? That's why those things come from, or where those things come from. All right, so find the area of each box in the pair. So if we find both of these, then I'm going to have 4x, and then this one is also going to be a length of 4, right? It's the same distance. So 4 times 3 is going to be 12. So the total area would be 4x plus 12. So same thing here. So this would be 7a, and then this one would be, you can put the 7 right there. It'd be 63. So our total area is 7a plus 63. All right, and then the next one is going to be 3x, and 2 times 3 is 6. So we get 3x plus 6. Okay, so there's a reason that we're doing this. So now we're going to put them together, right? So if you put the boxes together, well, let's talk about the lengths first. So it says write the expression that represents the total length of each segment. So if I talk about this length going all the way from the end on the left to the end on the right, what would we say for that length? Yeah, it's exactly x plus 9. You're going to add those two lengths together. So if x was 2, you'd have 2 plus 9, which would be 11, right? Yes.
Yeah, I go to.
Yeah, you're fine. Go ahead. So this next one is going to be x plus 4, right? And the last one is going to be a plus 2. So when you think about two rectangles pushed together like they are, you could talk about their total area in two different ways. You can do the total length times the total width, or you could talk about each individual box in these pictures. So you have this little chart to fill in. So it says the area as a product. So the area as a product is going to be like your length times your width. And this entire width was x plus 7. So do you guys see how it's 5 times x plus 7?
Yeah.
Does that make sense? All right, but if we talk about the sum of each area, the first rectangle is 5 times x, and the second rectangle is 5 times 7, which creates 35. So you have 5x plus 35. All right, so let's write them in two different ways. So our area is our product, length times width. So our length and width are going to be 3 times x plus 12. Does everybody see that? But if you talk about the individual rectangles, it's 3x times 3 times 12, which is 36. So you get a total of 3x plus 36. Do you see how that demonstrates the distributive property, where it's coming from, 3x plus 36? Okay, that's what I want you to kind of take away from this. Like, how do I get the distributive property? What happened here? How did we come up with it? All right, so this one is going to be 5 times a plus 8. And then our area is going to be 5a plus 40. All right, we got it? You know how you found out?
Yeah.
Okay, you're just twiddling your thumbs. I look down, he's like this. Just hanging out. All right, so combining like terms. So it says you're able to add and subtract terms with the same variables and the same exponents on those variables. Okay, if you're able to add or subtract terms, they are called like terms. Okay, so this, you can always think back to these rectangles. So if you think about it, if we had something that's x by x, and then we have two more x by x's, right? Then can't we say that this is 3x squared, right? I have 3 of the x squared boxes. So if I pushed them all together, I have 3 of them. But if I have something that's like 1 unit by 5 unit and something that's x squared, I can't say that I have like 2 x squareds. Do you guys understand this? This would be 5 plus x squared. I can't combine them and say, oh, I have 6 things. It doesn't work that way. Do you guys see what I'm saying? So you can always think back to the areas if you need to. So basically, like terms, we're not only going to have the same variables, but we're going to have the same exponents on those variables. So if I have 4xy and 2xy, these are what we call like terms. And we can combine them. So if I have 4xy plus 2xy, I get 6xy. Okay, so the important thing to notice is that I did not say 6x squared y squared. Do you guys see that? Or 8x squared y squared. I'm not multiplying. If you were multiplying, then yeah, when you do xy times xy, you'd have x squared y squared. But if you're just adding, they stay exactly the same, just like apples. If I have 4 apples plus 2 apples, I have a total of 6 apples. You don't change anything. You don't say apple squared, right? That's multiplication. That's weird. All right, and then we have just the minus 5 by itself, so we're going to hang that on the end, so minus 5. So 6xy minus 5.
Negative 5 plus 6x.
You could, yep. So you could also say negative 5 plus 6xy if you want to do it that way as well. Just make sure whatever sign was in front, like if you have a negative with the 5, then the negative is with the 5 here as well. All right, so the next one, we look for our like terms. So I have 5x squared and I have negative x squared.
Wait, so do you then have to take the 5x squared and the negative x squared and make it cube? Not cube.
Nope.
To the 4th?
You do not, because we are not multiplying them. So if we were multiplying, if I had 5x squared times an x squared, then yes, that would be 5x to the 4th. But since we're adding and subtracting them together, we just keep them the same. So what would it be? What do you think?
4x.
It is, because this is negative 1x squared, right? So if I have 5x squared minus a 1x squared, I get 4x squared. So let's just rearrange them so we can see our like terms. The 4x is all by itself. You guys see how there's no other things with x? So we're good. So we're going to say plus 4x. And then the last ones are the minus 17 and plus 10. So if we're combining our like terms, our 5x squared minus 1x squared, that makes, and then we still have the plus 4x. And then our negative 17 plus 10 is going to be negative 7. So that would be our final answer. Okay? All right, so go ahead and try the next one. It's a little bit harder. You have the distributive property involved. So when you distribute the 8n, you should have 4x minus 5 plus 16 minus 8x. Did you guys all have that for the first step?
Yeah.
So you distribute the 8n, 8 times 2, and 8 times negative 1x. And then you look for your like terms. So we have 4x and we have minus 8x. So if you need to write it in order, that's fine. 4x minus 8x. And then we have minus 5 plus 16. Those are other like terms. So 4x minus 8x is negative 4x, and negative 5 plus 16 is plus 11. So how many of you guys got that? Only Peter's claiming it? Okay, a couple more of you. Good. So it seems like the left side of the room gets this. Those the right side of the room get it. Did you guys get it?
Yeah, I was just working.
Okay, you were just working. Okay. So try the next one. Did you guys get negative 25x plus 2? Yep, you got it. Good. All right, so you don't have to show the step where you're rearranging the terms, but it is useful in Algebra 1 if you need to do that the first few times to understand. So a lot of times I'll just say, oh, negative 15 minus 10, that's going to be negative 25, and I write that without lining them next to each other. Okay, so that's kind of the goal in the end, is to be able to do that without writing that step. All right, so next one, we have fractions. So if you have fraction phobia, it's okay, we can handle this. We're getting good at fractions. We're going to multiply the 1/2 n. So I'm going to have 1/2 times 4. So if you need to write that out, that's fine. And then I have minus 1/2 times x. And then I have plus 3/4 x. So 1/2 times 4. So we're saying half of 4. 2. And then I have my minus 1/2 x plus 3/4 x. So I need to combine these two terms. I need to add them together. All right, so in order to do that, I need to have common denominators. So on the first one, the 1/2, I'm going to change it. What should I change it to? Yeah? 2 over 4. Yep. So I'm going to have 2 minus 2 over 4x plus 3 over 4x. So we got common denominators. We multiplied by 2 over 2 on the first fraction. So our final answer is going to be 2 plus 1/4 x. So negative 2 plus 3 is positive 1. All right, and then sometimes you do have some multiplication involved. So in this case, we have x squared times negative 4x squared. So when we multiply these, we end up getting negative 4 times x to the 4th, right? Because remember our expanded form? It would be x times negative 4 times x times x. There'd be 4 x's lined up, right? That's what we're doing. So then I have plus 7x to the 4th minus 8. And now I see, oh yeah, I do have like terms here. I have negative 4x to the 4th, and I have a 7x to the 4th. So same variables, x's, same exponents on those variables. So if I combine this one and this one, what do I get? Yeah, I get 3x to the 4th. That's it. All right. On a scale of 1 to 10, 10 being totally understand, where are you? Totally 10?
Yes,
5?
let's play Kahoot with this.
We have a Kahoot game, but you got to first understand the lesson, right?
I understand.
All right, so here's the little tricky one. All right, so I have negative 2/3 x squared times 6. So I'm multiplying there. So I need to multiply these. And it's a little scary. There's fractions.
Oh, it'd be 6 over 1.
You can think of it as 6 over 1. So we have negative 2/3
Don't we have to flip it because
x
it's
squared.
-2?
times 6 over 1. Nope, because it's not a negative exponent,
Okay.
so you don't have to move it around, right? It's just a negative number there. So what do we get when we multiply just that part? So what about on the top?
Simplify it.
Yeah, you could simplify. You could reduce down the 6 and the 3, right?
Yeah.
So if you reduce down the 6 and the 3, you get a 2 and a 1. Or you could have multiplied across the top, multiplied across the bottom, and then reduced. Okay. So if we reduce here, so we have negative 2x squared times 2, so I get negative 4x squared. So that's not so bad. So we have negative 4x squared starting out the expression. Then we have that minus x plus 5/4 x
Wait, so when you
minus
do
3x
x,
squared.
would it make it just 4x?
When I do minus x, good question. We are not like taking away the x's. So an x squared is representing some kind of like area, like an x by x shape. So taking away like x doesn't, I mean, there's no way to like subtract that area. So they are not what we would call like terms. So you can't combine them. It's like saying apples and oranges. Like you
Just
can't
because
say
it's not x
4
squared,
apples,
it
3
can't
oranges.
be. If it was
Right.
x squared.
If it was x squared, then you could. So is there anything else that is x squared?
Yeah.
Yeah. So we have negative 4x squared, and we have negative 3x squared, right? So when we combine, we get negative 7x squared. Is there anything that has an x? So we have negative x. Yeah, we have negative x and 5/4 x, right? So how am I going to combine those?
1/4 x plus negative x.
Yeah, so I think you're thinking of your mixed fractions, but let's go ahead and write this as like 4 over 4x, and it's a negative, right? Right, we're getting common denominators. Are you guys with me? Will, Ryan? You guys just chatty Cathy's. So we get negative 7x squared. Then I have minus 4 over 4x plus 5 over 4x. So I'm going to have plus 1 over 4x, like that. Okay, so those are some tricky ones. If you can do that one, you can do anything that's on the homework. It's as hard as they get. All right, so let's try the next one. So is the next one combining like terms?
Yep.
Okay, it's not. It's different. This one's different. What's different about this problem?
One is squared, one's not.
Yeah, they are not like terms.
So would that
Can I combine them though? What operation is between them basically?
subtract?
Is it addition, subtraction, multiplication?
Multiplication.
It's multiplication. So when you have two parentheses next to each other like that, that is multiplication.
But how could you put them together if they're not like terms?
So multiplication, like if I had x squared times x cubed, right, I can multiply those. I could say it's x to the 5th, right? Because what that is 2 x's, 3 x's, a total of 5 x's,
But
just like we did in the last chapter.
Negative 2RS to the 1. Look at it that way.
Yeah, like these are ones here.
Yeah.
Yeah, those are ones. So how about the number out front? What would I have?
Negative 16.
Negative 16. How many r's would I have total? So that's an r to the 1 as well. I'd have r to the 2, and then s to the 3. So don't forget the things that you've learned previously. Don't forget, hey, sometimes I just have multiplication. I'm just combining with my exponents. Yeah.
I'm really sorry, but can I go to the bathroom?
Yeah, you're fine. Are you not feeling very well?
No.
All right, so let's try some other ones. So I have 7 times 3 minus r plus 2 times r plus 5. Okay, so same idea. We still have distributive property. So when we distribute the 7 in, we're going to have 21 minus 7r, right? Do you guys see that? 7 times 3, 7 times negative r. And then I'm going to have plus 2r plus 10, like that. And then we combine our like terms. So when we combine our like terms, we're going to have negative 7r plus 2r. So I get negative 5r. All right, those were our like terms there. And then we have 21 plus 10. Now, a lot of my dyslexic students will have trouble with this because when they see the 21, they see that negative next to it, and in their head, they see negative 21. Does that make sense? So if you need to circle so you can say, okay, the sign in front of this is a plus, or if you need to put a plus in front of it so you know, okay, that's positive 21, you can do that. So we have 21 plus 10. So So 21 plus 10 is 31. All right, the next one has a lot of parentheses and brackets, right? So we're going to start all the way on the inside. So we're going to start with this 7 minus 3x plus 5. Now I'm going to distribute the negative. Do you guys remember what I mean by that? So that's like a negative 1 out there. So if you want to put a negative 1, that's fine. So we're going to have 8x plus 2. Then I have 7 minus 3x minus 5. So I distributed that negative into the parentheses. So if possible, you simplify what's inside the parenthesis or bracket, right? So can we simplify anything inside there? Yeah, the 5 and the 7, right? So I have 7 and I have minus 5. So I'm going to have 8x plus 2. I'll just do a regular parenthesis. 7 minus 5 is 2 minus 3x, like that. And then we continue to simplify. So what's my next step? Not yet, almost. Yeah, we're going to distribute that too, right? Because again, we have a number outside of the parentheses. We're going to distribute it in. So we get 8x plus 4 minus 6x, and now we combine those like terms. So now we have 8x minus 6x, so we get 2x plus 4. All right, so here we go. So the next one. So I have 2y, then I have 8 minus, so I'm distributing the negative n. So if you want to put a little negative 1 out there, that's fine. So I'm going to have 8 minus y minus 3. Then I have plus, and now I distribute the 2y in. Who can tell me what I have when I distribute the 2y in? Caitlin, you haven't gone yet. Can you do it? When you distribute the 2y in, what do you have? Like multiply the 2y in. 2 y to the second, minus 8y. Yep, good. All right, so we have that. Yeah, Peter?
Wait, how do you get negative 6 if it's 8x minus 3x?
8x minus, it's 8x minus 6x. Oh, wait, I see what you're saying. You're distributing the 2 in here. So
Okay.
2 times 2 is 4, 2 times negative 3x is negative 6x, and then you combine. All right, so again, let's combine our 8 and our negative 3. So I get 2y, and then I have 8 minus 3 is 5. So times 5 minus y, plus 2y squared minus 8y. So we get 10y minus 2y squared plus 2y squared minus 8y. So what do you think about those y squareds?
Can you slow down a little bit?
Yeah. Okay, so you get the part where we distributed the 2y in, like that. So I have 2y times 5 is 10y. 2y times negative y is 2y squared. Well, negative 2y squared. All right, now look for your like terms. So we have negative 2y squared plus 2y squared. Be careful, not 4 though. Negative 2 plus 2, yeah. They cancel each other out. So do you think I have to write 0y squared? No. So 0y squared, you can just leave it. So when that happens, I just kind of cross them out. Say, oh, okay, those canceled. All right, now we have 10y minus 8y. So 10y minus 8y is 2y. So all of that simplified all the way down. It's equivalent to 2y. Isn't that crazy? Start out with that big mess and you get down to 2y. All right. Let's see how much we have. You guys want to try number 12? 12 by yourself first? You need a second? Okay, go ahead and try 12.